luck. I feared that there would be no one, because like always, it's like, again, the Super Mario guy now. So, we're going to, basically, the talk that we're going to share today, it's kind of a complementary one to the one in the morning. So if you came during the morning, there are some slides that you already saw, that you've already seen. So some things are new, some things might be the same, some things are slightly different. I'll give more details in some parts. But all in all, I think it's very complementary to what we've had this morning, okay? So for all of you who weren't there, well, shame on you. You should have, okay? So that's how it goes. So this is the 10 commandments for iOS software development. It all started like the 10 commandments for iPhone software development, but then again, the iPad came and it changed everything, including my site. So just a quick introduction. As my family name suggests, I come from Argentina. I have a Polish family name, a Swiss passport, and a Bolivian wife, okay? So that summarizes the picture. Okay, so we can talk over a beer. Later I will tell you the whole story about my grandfather in the 30s, in the middle of the Great Depression, going to Argentina, blah, blah, blah. I have this company called Kosmaczewski in Switzerland. These are the fine locations on the web where you can find more about this company, and I suggest, strongly suggest, because it's awesome. You should like my page, and in Facebook, and also follow me on Twitter. I have a couple of apps on the App Store. Mine, others for my clients as well, and I speak at some events like this one. I will add the logo of this event, of course, for my next talk. Okay, so just some questions to get a feeling about all of you. Who's completely new to iOS? Oh, nice. And how many of you came to my talk this morning? Okay, so there's a mix of people, like let's say a 60-40. Okay, that's cool. That's cool. Which technology do you use? For example, let's say who uses Java? Okay, very well. Who uses C++? Okay, Ruby on Rails, Django, this kind of agile web frameworks. Somebody? Less people. Okay, but still. Very well. And .NET, of course. Yeah, very good. And programming languages, well, I've already asked that question mixed with the previous question. So, this is all about 10 commandments. I'm going to give you my own tips about programming for the iOS platform, okay? Things that work, things that don't work, things to watch out, these kind of things, okay? So, this is the kind of thing that we're talking about, you know, the tablets of the Lord. This is the slide that I've shown this morning, but it's so talking and it's so appropriate for this occasion, you know? Because we are starting with our first commandment. And this is that you should manage memory properly. Okay? So now, of course, there's this new ARC thing that I've mentioned this morning, which is the automatic reference counting. I'm not going to talk about that. It's a huge subject. However, I strongly believe that for you to understand well how iOS works, even if you use ARC, automatic reference counting in iOS 5, you have to understand how memory management works. So this is a recap of what we've seen this morning. You've had plenty of applications. Users have the impression that their iPhone can run anything and everything at the same time. Actually, it's a big illusion. Actually, the iPhone has very limited capacity. The iPhone and the iPad are very small devices. They have the quantity of RAM that we used to have in our computers, let's say 5, 7, almost 10 years ago. Okay, so quick recap: the first two iPhones, which have been completely phased out, have 128 megabytes of RAM. The iPhone 3GS and the iPad 1, double that, and the latest editions of the iPad and the iPhone, as well as the iPod Touch, double that, half a gigabyte. Okay, but then again, that's not a lot when you know that in cold start, cold boot, iOS can take up to 70 megabytes. Okay, and there's no sub file and no virtual memory. That means that when there's no more memory, there's no more memory. Okay, and that means that the application will be removed from memory. After a couple of strikes, you will be called you will be reminded to attention by the operating system every so often, but it pretty much might signify the end of your operation. And most importantly, and it's very well known, the iOS does not feature a classical garbage collector. Okay, so it's not the kind of garbage collection that you're used to in Java or .NET, where once an object has been left out in memory, eventually the garbage collector will wake up and will swipe the whole heap, asking each object, oh, is there anyone pointing to you? Oh no, poor you, then come with me. There's no such thing for performance review, which is pretty much how a garbage collector runs. Remember, that's why you have your Java app doing like that, and then you continue working. So they do want this kind of interactions with IRE. It's not exactly like that, but it gives a picture of how these things go. Actually, IRS uses a rather primitive, it must be said, version of garbage collection based on retain counts. That is, an object will be increasing and decreasing a variable called the retain count, okay, and as soon as that object reaches 0, that object will be reclaimed from memory. So, just to explain how this goes, I'm going to jump to another presentation that I have prepared that pretty much explains, it's a very short one, that explains how all of this works together. So here you have a very, very simple set of slides which will have in the first column on the left the code, the layout of the objects on the stack, and then on the heap on the far left, okay? So first of all, you have to know that there's some location in memory which is nil, which is usually 0x0, okay? Somewhere the place that doesn't exist, and just signaling it like that. And then you have to know as well that since Objective-C is a dynamic language, there are objects that represent the classes. In this case, I represented the object of the NSArray class. It's a meta object, if you want. Then I define a variable of type class. Okay, a class variable can point to any of those class objects which exist in the runtime. And to begin with, that variable in the stack points to nil. Okay. Then I create a variable that will point to an instance of NSArray. Okay, and for the moment it points to nil. So I'm completely blinded right now because of the photo. Thank you. No, it's okay. Not your fault. And then again, what I do, I send to the array class, I send the message to, I make the array CLS pointer to point to the object in memory that represent all NS arrays. So now I have my variable, my pointer goes to green because it's pointing to a good location in memory, not nil. And then I will send the alloc message to that object. When I send the alloc message, what I get in return, it's basically a new location in instance, a new location in memory that is non-initialized but has the proper size to represent an NS array. And then to the return of that call, I send the init message. And that will turn the instance to green because now the NS array is properly configured and ready to be used. That's how basic creation of object works in Objective-C. When you do an alloc, the structure that you get in memory has a retain count of 1. And this is the important thing about this slide, is this small red number. Okay? It has a retain count of 1. That means that this special garbage collector of the iPhone will not touch this object because it has a retain count of 1. Somewhere in the code, I pass this pointer to someone else who will execute some operation over the array. So it will do a retain. This piece of code somewhere will do a retain on this object. That means that my retain count goes to 2. I have now 2 objects somewhere who are interested in this array. When that piece of code ends up the work they are doing, the array instance receives a release message that makes the counter to go to 1, and at the end of the operation, when everything is done, or when the application goes to sleep, or when something happens, I send, there you go, another release message to that object, and now my instance has a retain count of 0. That means that at the next cycle of the garbage collection in the iPhone, this object will be reclaimed, and very importantly, now my new array pointer contains a bad address in memory, so I shouldn't use it because I might crash the application. So as always, you should change the value of the new array pointer to nil so that your application doesn't crash. Because this is an interesting concept in Objective-C. You can send messages to nil. There is no null exception in Objective-C. When you send the message to null, nothing happens. That's everything it goes. And I personally believe is one of the reasons why Mac applications are so stable. Because actually, sometimes they don't work, but they don't crash. But this has a very deep meaning, because Apple, basically, they care so much about the user experience that they don't want the applications to crash because of null pointer experience. So they basically made the language to react to this situation doing nothing, basically. So this is how it goes. This is a very, very useful way. It's very graphical. I hope it's useful to everyone. I always find it very useful to show this to people so that you all see what's going on. And there we go. So the basic rule for memory management, as always, whenever you do an alloc, a retain, or a copy on an object, you must do a release. You become owner of the object. Whenever you do an alloc, you do a retain, you do a copy, you're owner of that object, you must get rid of it using a release. It's the same kind of equilibrium you have in C with free and malloc. It's the same kind of equilibrium you have in C++ between new and delete. You have to equilibrate one with the other, okay? Same kind of things. Then remember that Objective-C only allows objects on the heap. So that's a heap for those who've never seen a heap before. That means that you don't have automatic objects on the stack. Then again, this is a stack. And this is the kind of things I'm talking about. In C++, you can create objects on the stack, which are reclaimed automatically when they go out of scope. Really handy, particularly for automatic pointers. They're really cool, but you cannot have that in Objective-C. All the objects are created on the heap. Objective-C is a dynamic language. So that means that the compiler actually performs very little checks. The compiler is a very fast one. He does just a bit of checking in terms of types and messages and method resolutions and that, but it's really fast. Actually, it does only perform a bit fast compilation. The linker does the rest, and then you have a crash at runtime. So it's very important to pay attention to all warnings. This is something that C++ developers know all too well. There's a lot of books who write about the subject of setting warnings to on. So here I'm showing the project settings to get this variable, which is the most important one that you have to set. If there's one variable that you have to set in your project, whenever you work in Xcode, turn warnings as errors. It's a recommended practice in C++, but even more in Objective-C. And I make it part of my daily routine. When I create a new project, treat warnings as errors, and then you move on. Okay? Then there's another one to set the warnings of Interface Builder. I show it as well for reference. You can do it on the command line if you're into that kind of thing, but Xcode does it for you. These two books basically explain the rationale behind treating warnings as errors. Warnings are tips from the compiler telling you, hey, there's something fishy here. Here you're not using this variable. Why? It might be that it's set up as an external and somebody will be setting the value somewhere outside in your code, whatever. But you have to make your intentions explicit to the compiler. It forces you to write explicit code, and explicit code is good, TM, okay? These are the kind of things that you have to do. So I recommend checking this. Well, why warnings? There are a couple of warnings that are very important. For example, deprecated symbols. iOS is a platform that is moving all the time. From version 2, when I started working with the SDK, to now version 5, lots of APIs have come and gone. Whenever you receive a deprecated warning, you can be sure that at the next revision next year, this thing will not compile anymore because the method will not exist anymore. The calling method names not declared in method headers, that might as well throw you a warning. You might want to create a separate header file with a category and include those methods there. Calling methods belonging to implicit protocols. Implicit protocols it's a feature in Objective-C. Actually, it's like an interface in Java, but you don't have to write the interface itself. But you don't want to have that. You want to have explicit protocols all the time. So don't use implicit protocols. Forgetting to return a result in methods that don't return voids. So let's say, for example, you have a method that returns an int, and you don't put the return value at the end. Well, you will have a warning, and it's important that you do not leave these things unattended. Forgetting to import a header file of a class declared as forward, and downcasting values and pointers implicitly. These kind of things will pop up as errors in your code. It's a healthy practice. I really recommend that you do this all the time. Okay, frankly, it has saved me countless hours of debugging. It gives you lots of feedback to begin with, and you learn a lot as well about how Objective-C works, because there are a lot of things that you probably don't care because it's just a warning. So the solution is always to make your intentions explicit to the compiler. Okay, so make implicit protocols explicit. That's what I said. Categories for private methods. Okay, so there's not a concept of private methods per se in Objective-C. The only thing you're doing is hiding them. Okay, so it's something that you can do, and it helps as well document the code, and it's really important. Turn implicit conversions into explicit ones. Use the @class forward declaration in the interface, and the import always in the implementation. That also reduces dependencies between header files, which also reduces the time of the compilation of your project. This is very important. Whenever you have header files between themselves, they should not include them. They should not include themselves. They should forward the definitions, and you must import the classes directly in the implementation file. This reduces the compilation time. Very well, I have a whole article explaining this as well, so please check it out. If you put compiler warnings in my blog, you will find it. Number 3, honor the human interface guidelines. Well, you've seen this one. I've shown it this morning. It's a very nice document, 120 pages, complemented with this awesome book on O'Reilly, the iPhone user experience, that basically shows what should be done and shouldn't be done when you are designing an iPhone application. That also means work with the designer. That's what I said as a joke a couple of minutes ago, but actually it's true. Try to work with the designer because we are trying to avoid rejections. There are rejections that are based solely on the mismanagement of the iPhone user interface management. So read the App Store approval process. There's a whole lot of information about it. You will see that one of the items is the respect of the human interface. There's a lot of also items online, lots of different resources that you can find that I found useful to fight that. I even wrote an article about risk management in iPhone projects. One of the risks is, of course, the rejection is a major risk of any iPhone project that you publish publicly on the App Store. So it's important that you take these risks, that you measure them, not that you avoid them, but you must measure them. You must know them and take action. Of course, you want to avoid this kind of applications, which is the one I showed this morning. Okay, for those who haven't seen it, it's an old Palm developer who started writing iPhone applications in 2008, and frankly, it's hideous, you can say. And also, you might want to avoid very bad reviews, like the worst Twitter client ever. This is something that I showed this morning. I won't go into it, but basically the last line is very, very funny. If you buy this, we are not friends anymore. You don't want this kind of reviews of your applications when you submit them to the App Store. So it's very important. It's part of your marketing message. You have to have a nice application. You should optimize for performance. It's really important to realize that these machines, they don't have a very big processor, okay? They have the processing power of the computers we had 10 years ago, okay? We're talking about processors of 1 gigahertz in the best of cases. The iPhone 3GS is around 800 megahertz. So there's a lot of constraints in these little machines, particularly in iPhones. So basically when you're drawing, when you're scrolling, when you're launching the application, when you load files and data, and when you manage your power and your battery life, you have to take special care. These are the 4 biggest things. We're going to go one by one because they're very important. First of all, drawing and scrolling. UI user classes are already optimized for performance. So if you are using UI buttons, UI sliders, UI whatever kind of object that you have in the toolkit, it's okay. They are already optimized for display, so they're really good. So you have to pay attention when you create your custom views, okay? So you shouldn't redraw the whole rectangle of the whole view, just redraw the parts of the screen where things are moving, where you have defined that there was a change. Okay, this way you are going to optimize the redrawing and make it faster. Even if these machines have GPU, okay, that doesn't mean that you cannot give a hand so that the whole experience of your user is better. Very important to cache static objects. If you have views that don't change, keep them in memory, don't recreate them. Alloc init is an expensive operation in the runtime in general, so you better Keep an object already created, keep it in an instance somewhere, be ready to release it if there's a memory warning, but don't recreate them every time when you're scrolling, particularly if you have a long list. Don't recreate objects all the time. Keep them aside, reuse them, change their properties. It's much cheaper than starting from scratch. Using opaque views also helps a lot. Allocating while scrolling, reusing table cells, collapsing view hierarchies. I'm going back to this slide. Using opaque views, why it is important? Because there's a compositing engine on the iPhone, okay? So everything you see on the iPhone basically is like a Photoshop set of layers in Photoshop that you see from top, and the final image is a composition with all of the things. If you have opaque views, there's a Boolean opaque in UI view, in the UI view class, which is the mother class of all views in the iPhone. If you have this Boolean set to true, the compositing engine can go much faster. Okay, there's optimization in that sense. So be careful to work with the designer so that your design can be opaque instead of having fancy transparencies all over the place. This is a very important point to explain to designers when you work with them, okay, because it directly impacts user performance. Now, application launch. You don't have to be lazy. The important part about application launch is that you only load in memory whatever you need when the user starts the application. If the user doesn't need the network connection or loading that big file when the application loads, don't do it. Leave it for later. Objective-C is a super lazy loading language, which basically can load on demand lots of things for you. Keep those things on disk. Don't read them until you really need them. That will speed up the application's launch. And applications that launch faster are, nice. The user feels powerful and productive all of a sudden. And mobile devices are used in contexts of very little attention. You're in the street, you're like that. You want to find the nearest coffee shop. You don't want to wait 2-5 minutes for the application to start. I mean, you will forget that you wanted the coffee, and something else will pop. Then you have a notification that your boss is yelling at you, and you go back to your work, and you forgot that you wanted your coffee. So think about the fact that you're using applications in a mobile context. Mobile context, little attention. Little attention, fast load time. Okay, this is very important. Then files and data, super important. If you're using large data sets, use core data. Core data is an object relational mapper that allows you to store in SQLite databases the contents of a large tree of objects in memory. So it's super easy to use, super easy to manage. It manages versioning, so if your model changes over time, you can add fields and you have your data model being migrated for you with the alter table done automatically in the background for you. It's actually quite magic. It's not that complex to use, but it's worth a complete session. We could do like a 2-hour session on core data and we would just touch on the tip of the iceberg. It's an awesome framework. Large files in memory, avoid as much as you can. Map them if you can. Try to read parts of your files. If you have large data sets that you have to read sequentially, use as much as possible sequential XML parsers. If you have a long response that comes from your server, like a SOAP message. SOAP messages are always huge. You have so many different envelopes, and you only wanted the Boolean in the middle, right? But frankly, then what you do, you download directly to the disk, and then you create an XML parser instance, and you go sequentially until you find your value, and then you discard the rest. But go with SACS style parsers. They manage, they are a bit slower, but depending on what you want to do, the memory will be better managed for you in those cases than if you load everything in the DOM and then you have a data structure of 20 megabytes in memory and you just wanted the Boolean in the middle. I mean, it's less code because let's be frank, SACS parsers suck. I mean, you have to write a lot of code and parsing and everything and keeping track and reading that tag. Try to avoid DOM if at all possible. Very well, power management. This is the last topic. Be very aware of the fact that network on a mobile device like the iPhone is very expensive in terms of energy. If you're using a lot of a 3G connection, your battery goes like that, you can't see it. Because 3G connectivity, it's very expensive. Wi-Fi, a bit less, but still, Wi-Fi connections are closed after a while on the iPhone and the iPod Touch to preserve battery life, basically. Prefer chunky to chatty is the usual da-da-da. If you can, instead of having a sequence of 3 requests, if you can have your database and server-side developers to give you an API with just one call that returns everything you need, please do it. Please do it. You will see the difference in the memory consumption, okay? So, dorsal test in the device. This is super important. I mean, you've seen in the demo today that there's this very nice simulator that is bundled with iOS, with Xcode and everything. But actually the simulator has a lot of drawbacks. So typically you don't have the camera, you don't have access to accelerometer, you cannot shake your Mac, you know, if you're doing code that you are working on a game, you're like shaking the Mac like crazy. No, you're going to break it. You don't have the compass, the battery. Now you have the GPS. I have to update that slide. Now you have the possibility of knowing where you are if you are connected to a Wi-Fi network. It used to be until iOS 4 that you would be in your simulator always in Cupertino. You would be in one, like the only location you could get from the simulator was infinite loop number 1, which is okay, but I mean you would like to be in your home, and we all know we don't live in Cupertino, or at least not me. And then again, one of the most important things is speed about testing on the device. Why? Because in your Mac you have a Core Duo 2 or you have an i7 with 2.8 gigahertz of speed, and you have 4 or 8 gigabytes of RAM. Maybe you have a quad-core Power Mac last generation, you know, like 18 cores running, 16 cores running. No. I mean, if you want to really test the speed of your application, you know, the rule of thumb is always connecting the cable, running your code in it. Of course, pay attention, because sometimes depending on what you do, it can get really heavy. But another reflex that you should have is to keep your old 3GS 4 iPod Touches. As soon as you have finished your family quota, because we all have families and we all want to have the devices that we had last year because we are getting the new 4S. So as soon as you've given all your family all the devices that they wanted, keep a couple of devices for you for testing in old configuration. I have at home a couple of iPhone 3G with iOS 4, and it's great for testing the current applications with a very old device, because the iPhone 3G, you will get memory warnings all the time. It's slow as hell. It's not even a 3GS. So actually, you can make awesome software. It runs really beautifully afterwards in the iPhone 4. Okay. So remember to keep your old devices. It's really, really important. Number 6, you shall unleash the power of instruments. Instruments is awesome. It's absolutely. I cannot tell how much money it has saved me, how much white hair I don't have because of it. Remember, it's very easy to use. From Xcode, product, profile, you select the kind of probe that you want to inject, because you can think of instruments like, you know, you put your application in the doctor, like in Grey's Anatomy or these kind of shows, when you have the ambulance coming and you have, you know, the doctors running and telling each other completely incomprehensibly blah blah about, yeah, you have a person with a double fracture of the pericardium, and you're like, you don't understand a thing what's going on, but you're suffering like hell. Well, this is the same. You take your code that doesn't work, you put lots of probe on it saying, okay, how much memory, how much network bandwidth, how many objects do I have in memory? Am I responding well to memory warnings here and there? And then you get beautiful graphs that you can store. You can save them for later comparison to see if your modifications worked or not. Actually, it's really, really good. I strongly recommend that you get familiar with instruments. Frankly, it's absolutely awesome. Number 7, those are to use PNG files. Whenever you work with the designer, they will come back to you first with a PSD file. Photoshop is kind of a standard. I mean, when you have a designer working for you, they will give you this Photoshop file, which is fine, but you cannot use it as that. You have to cut, create the sprites, if you have an animation or something, the buttons, you know, the background images. Well, whatever you create, do it in PNG. It has lots of advantages. It turns out that when you build your application, Xcode compresses PNGs further. So it's actually a proprietary version of PNG created by Apple that keeps the alpha channels and the rich color information, but at a much slower size. That means that it has a lower memory footprint than other formats, particularly JPEG. Okay, it has also The nice property that PNG is supported by all editors is an open format. You can really pretty much create it in any application, and it has great quality. When you compare the same application, the same image using JPEG or PNG, I don't know if it's clear enough, but you can see the detailing of JPEG and the jazzy contours of solid colors is not good. In PNG, it's simply brilliant, it's superb. And another important thing is transparency. The compositing engine of the iPhone takes into account the alpha channel of your PNG files and will use it as if it were another UI view. So that's really cool because you get transparencies for free. Very important whenever you are creating your application, provide all the standard icons, of course in PNG format. So there's a technical QA in developer.apple.com that basically tells you exactly for each kind of application, universal or not, iPad or iPhone or both, which kind of icons, which are the names of those icons, and where you have to place them, and so on and so forth. Remember that the app icon is the most important thing of your applications. The first impression that a user will have of your app when he sees it or when she sees it on the App Store. Okay, we were talking about this with some guys before getting into the room a while ago, and please hire a good designer for your application icon. It's super important. Design your application icon in maximum quality, then reduce the size. Don't design it at small sizes. Do not apply any kind of effects, so you don't need to apply rounded corners or the little colors, the little brilliance. It will be added automatically for you. This is really handy. When you create your file, create always a 512 TIFF version at 72 dpi to be sent to the App Store. That's the icon that will be shown in the App Store. Okay? But you have to create your icons bigger. Make them in vectorial format, as big as you can, okay? And keep them safe, because if your app is successful, Apple will come back to you and will tell you that they need your icon to put on big banners on WDC on the launch of the next iPhone on June of next year. And it has happened to a couple of friends of mine in Switzerland. They have their applications featured. So they had to quickly create artwork in very big sizes, and you'd better have the original Illustrator file, so think about it, okay? Because nobody's exempt from success, like French people say. No, really, it's a saying, it's really fun. Nobody's exempt from success. That doesn't mean that it will happen, but, you know. Number 8, those should use static analysis. Static analysis is actually quite awesome and it's super easy to use. Whenever you start your project, you're going to be able to use the power of the LLVM C-Lang static analyzer, which is an open source project that you can download separately that provides static analysis services for C, C++, and Objective-C code, and some others. I think it's extensible to other grammars as well. It's completely integrated into Xcode, so basically that means that whenever you build your code, you can have information like this, including the exact description of what is the problem with your code. This is like a second level of warnings. Okay, this is why I like it, because it provides me like a secondary level that the compiler is not able to get me, but the static analyzer can. And basically, it also shows, when you double click on any of these warnings, you will get the sequence of arrows that shows the sequence in the code that will lead you to a particular error. I cannot tell you how useful this is. So what you can do is basically follow this technical note, which is called iOS Debugging Magic, that contains this and many other tips. You can set up a tremendous bunch of variables. Thank you. Tremendous bunch of variables all over the place in your Xcode project to get warnings about lots of different things. Frankly, go on, use them. Use this Debugging Magic cheat sheet. Your code will be better. Your code will suffer less aging, will evolve gracefully. In 2 years' time, you will open it up in Xcode 5 or 6, and it will compile maybe with 1 or 2 new warnings that, of course, were unheard of when you created the project in the first place. But that's okay. But you will not be dragging lots of legacy warnings. Okay, this is a fast evolving technology. iOS is changing every year. Okay, every year we have new stuff coming up. So number 9. You should care about accessibility. And let me tell you a story. This is a very nice story. I was giving this talk last year in London, And after the talk, I had at the time 10 commandments, and now I have 11 actually. This is the 11th commandment. I have pushed others to the bottom of the list, but this is very important in the sense that I had a blind man coming up to me. At the center, I said, you forgot a commandment. I look at him and says, I'm blind, as you can see, and he showed me how to use his iPhone and how he can get aural feedback where he has his finger. The iPhone is absolutely amazing for this thing. I was in the floor. I couldn't believe it because I had never seen it live. The guy lived with his iPhone. He could find apps. He could go to Google Maps. He could search his contacts. He was reading email, everything. And everything because those developers were using the accessibility properties in Xcode. So basically there's a set of properties available whenever you select a button or a label, and this is the accessibility section in the utilities pane of Xcode. Please, it's really worth it. It's so simple. It's just a couple of texts here and there, and you will have your application that it's usable by people with disabilities of this kind. And it's amazing that the technology allows us to have a pure touchscreen device like this to be used by blind people. I cannot state this too much. Please use it. There's no reason not to do it. It's as easy as that. So it's a call to action. Okay? So whatever your apps you're using or you're creating now, you put accessibility because it's really important. Okay? We have to care about each other, and I think this is a little thought and a little something that makes really a difference. It's really important. Number 10 is the 10th commandment. And the 10th commandment is that you should have project management hygiene, okay? So you should care about the little details about your project, about how you manage your team, okay? It's very important to have good A-list players like Steve Jobs would say. It's very important to have good developer working conditions, quiet, a bit isolated, but in such a way that they can still work as a team, in such a way that they can concentrate and create good code and be in the zone, you're in the correct mood. Use prototypes. Xcode is great for throwing a quick application. You've seen me this morning creating this small web browser. I mean, you can do these kind of things in really a couple of minutes, literally. So use it. Create prototypes. Iterate over that. Use quality management measures, okay? It's really important to create unit tests. There's also instruments allows you also to create user level testings. That is, you can script the whole usage of your application, simulating tabs all over the place. You can script that and use instruments to perform those tests. So please do use them as well, and please organize your code. Don't throw resources, images, and code files, .h and .m all over the place. Organize your code, and I provide quite a few tips also in another article, which is called Code Organization in Xcode Projects. Take care about your project. I mean, your code is your fundamental asset. In our craft, source code is really something that has to become an asset and not a liability. If we don't care of the code, it becomes a liability. Code rots over time. It seems completely ridiculous, but I'm pretty sure it has happened to many of you. So it's really important to take care. But then the 11th commandment, because there were only 10, but now there's the 11th, as I told you. And the 11th commandment is that you have fun. You should have fun. This is a great technology to work in. The amazing things developers are coming up with iOS devices. So please have fun, download apps, check out what they do, share code. The amount of code that there's on the open source space, if you check GitHub, and you see the amount of open source stuff that's been published for the iPhone, it's outstanding, given the youth of this platform to have so much code of so much quality. It's really great. So please, that's what I want to tell you today. So let's make a quick recap. Manage memory properly, remove compiler warnings, human interface guidelines, optimize for performance, testing the device, then know your developer tools. Of course, use PNG files, use static analysis, care about accessibility, super important, and have project management hygiene, and finally, have fun and be creative, okay? Create new stuff because it's really great. So having said that, thank you very much, and I hope you enjoyed the talk.